I'd like to welcome everyone to our webinar on how to turn your prototype into an idea. How to turn your idea into a prototype. See, we're prototyping this presentation over here as well. Please note that this webinar will be recorded and sent out in a follow-up email for your convenience. So don't feel like you have to take copious notes throughout the presentation. We will also have a Q&A session at the end of the presentation. So if you do have questions along the way, do submit them via the chat box, and we'll make sure we get to as many as possible at the end of the presentation. Joining us this morning is our expert on prototyping, Keaton Andersen, an engineer at Arrow Electronics. Some of you may have heard about a partnership that Indiegogo has with Arrow Electronics. Through our joint certification program with both Arrow and IBM, we're helping hardware and IoT entrepreneurs bring their idea to life, and more specifically, perfect their prototype and get production ready. Through the Arrow certification program, entrepreneurs like yourself can get access to extra promotion through newsletter features, blog posts, and through webinars and events such as this one. You can also get access to flash funding. Last year, Arrow Electronics gave away a total of $1 million in cash prizes to certified Indiegogo campaigners, and we expect them to give away more this year. In fact, a little birdie told us Arrow's next prize will be a whopping $100,000 in cash. While everyone loves promotion and funding, the real meat of the partnership, however, lies in Arrow's one-to-one engineering support, helping you to build your product. Arrow also offers campaigners access to and exclusive discounts on components and other tools. Finally, once you earn that certification badge, we've found that Indiegogo campaigners who are Arrow certified on average raise more money and are more likely to hit their campaign goal. But enough about the program. Let's let the expert speak for himself. Please welcome Keaton Andersen from Arrow Electronics.
Introduction, appreciate it. So I'm just going to kind of give a little bit of background. So, I'm getting a little bit of feedback there. Okay. Hey, Indiegogo team, can you guys mute yourself? Thank you. All right. So I'm going to kind of go through, my background is I'm an applications engineer at Arrow.com, and I'm here just to kind of go through and what exactly we're going to be going through. Okay, chat's saying there's not a video yet, so we'll have to check on that. I'm going to go ahead and just kind of begin talking through some of the points, and we'll make sure that if anyone's having issue getting kind of the video set up, we'll go through that. So first thing we want to cover is kind of why you would want to build a prototype. So when we look at this kind of field, most of the time people who are getting ready to start tech campaigns go, what are some of those steps that I'm going to be working along the way to be able to go through and see how people want to see? That's what they're asking for. Got it. All right. Okay. So a lot of times what people are saying that they essentially are wanting to see from this is we're talking about the multiple stages that you're going to go through for building your product. So with that, essentially what you're looking at is you kind of have this ideation phase, and then you're going to move through and kind of begin your prototyping phase, and that's just one step on the way to manufacturing. Why it is so important is that to be able to show people essentially what you're doing and essentially to be able for them to get a better feel for what your product's going to look like, they need to have steps between what the finished product looks and essentially where you kind of have your general idea. So with that, what we've seen is that campaigns who are have working prototypes launch, and they essentially raise a bunch more money, 186% more money than campaigns who don't. And it kind of makes sense in terms of the fact that backers are able to see that the progress that you're making when you're doing a prototype essentially allows you to kind of give steps along the way of where you're going to be going with it. It doesn't just have to be all one big chunk, and your backers will feel more confident in the fact that your product's actually going to be heading towards market. It won't just be something that they don't get any updates or they're not able to talk to it. They can start to see as boards get produced, as they see proof of concept, and that'll eventually kind of help you be able to continue to raise more funds as you go along. But honestly, it's not just the backers who want to do it. If you aren't able to have a prototype available for your product, you're going to potentially miss out on some available marketing and industry reviews that you could be looking at. So with that, when you're going through and being able to build your prototype, essentially people will come to you and say, man, this is a really revolutionary idea. This is the next big thing. I want to get in earlier. I want to see how you're going through the process. And some of those interviews will start to build traffic for you. You'll be able to kind of get your product name out there and help you kind of set up further along the path than you might have been able to do if you didn't have a prototype. So looking at that, what are some of the factors you should consider when you're building a prototype? So the big questions that we're looking at here is how complex are your design? How many engineers do you have? Do you have designs and layouts? Do you already have parts? And can it be manufactured at scale? And all of these are really important questions to be looking at when you're doing your design. So if your design is going to be too complex and you don't have too many engineers to do it, essentially when you're going through and kind of building that prototype, it will take you an additional amount of time. And it's important to launch at the right point with your design. If you're too far out, longer term, what you're going to be able to do is going to kind of hold you back in terms of how much funding you're going to be able to raise. The earlier on that you're able to start this prototype, then quicker you're going to be able to hit manufacturing, actually begin to get your product shipped. So we kind of just made a note here that essentially if you're looking like you're more than 3 months out of being able to get your design prototype done, your design is going to be very complex, and it's something to keep in mind about when you should be launching and how you should be handling the campaign going forward. So I'll go into kind of the basic stages of prototypes to talk about what will work best and essentially what are some different areas that you should be hitting as you're going along your path. So the first thing to look at here is a visual prototype. What we're talking about here is kind of just what is the form and function of your product going to look like. It essentially can just be kind of modeled by potentially shape. And as you're kind of starting your initial design, and keep in mind, we're kind of keeping a heavy hardware focus on this. But essentially what you're going to be looking at here is how am I transitioning this block diagram and what do I eventually want this to look like? And why this is important is as you're going through the steps on building your prototype, knowing what the end goal of how it's going to look is really important, because as you begin to build your board, as you begin to do the layout of it, if you don't know what size it's going to be, then you essentially won't be able to kind of get your specifications down for what parts you'll need. You might have to do things that are smaller. You might have to do things that are more low power to be able to actually fit it in your design. For example, if it's something that's battery based, you're definitely going to need to make sure that you're trying to keep things as low power as possible, and you're probably going to want to have it pretty small. Otherwise, it's going to be hard to replace those batteries as time goes on. The next stage we'll look at here is then the proof of concept prototype. So you've kind of defined, hey, loosely longer term, I know what I'm going to be doing in terms of how big it should be, visually what it's going to look like. I might even have a rough sketch and kind of how that is built. From then a proof of concept stage, now we need to be looking at how do I breadboard this? How does it start to look from a functionality perspective? In many circumstances, this might be done on a Raspberry Pi, this might be done on an Arduino, but you need to essentially be able to go through and prove the thing that I want to do is feasibly done, and now my backers can begin to see how that idea begins to shape up longer term. It really is important to make sure that as you're kind of going through this, once you've hit this stage where you can actually start to breadboard it out, that's pretty much the next step that will move you forward to start to build your own board. So if it's either, again, a breadboard or a series of development boards, at the point in time that you could hand it to somebody and kind of walk them through the steps of how you might use your product, that's one area that's going to be able to enable you to showcase that, be it via a working demo or alpha testers potentially as well. All right, so let's go into the presentation prototype. What we're talking about here is that we're moving one step past that breadboard phase. So no longer is it going to be something that essentially you're able to just kind of show it roughly on a kind of a sketch there, but now we need to start to be able to show it forward to potential backers as well as customers looking for it. So it's not just going to be just kind of a rough outline of it. It's going to start to look at what does plastics look like on this? What is the first run of it? And it may just be, you're not going to have your Apple iPhone first run, that kind of thing. What you're going to have is probably a square box that you've put it in and be able to say, okay, if I were to take this to somebody, they know what inputs and outputs on this look like. They're able to kind of work with my product, and they can engage with it even if it's not perfectly pretty yet. This is definitely somewhere where you're still trying to figure out potentially the manufacturing process, and you may not have your own boards completely done just yet. And then the final one that we're going to look at here is kind of the factory sample. So this is going to be the first run that comes off of a production line for you to be able to look at. So in terms of manufacturing, you'll have prototyping levels of boards, and then eventually you'll scale up towards production levels. And this is really where you want to get to, is to be able to do a factory sample. At this point in time, you're in kind of a quality assurance phase, and you're doing testing to see, is my board working as intended? Are all the functions there? If I do this, does it cause an error? Really trying to make sure that you're working out all the bugs that could potentially be issues for your product at the end of the line. Essentially here, you need to make sure that the board is as close to ready for assembly as possible, keeping in mind essentially that parts that are hand assembled are going to be longer term to be able to get those boards done, as well as that when you're looking at scaling, it's going to be harder to be able to do that if you have to have people pushing together essentially Raspberry Pis and shields, or along those lines. That manual labor is going to slow down your manufacturing process significantly. So by this point in time, you should have a board spun, and it should be kind of your own IP that you're working with. So let's talk about what these kind of stages look like in terms of building a prototype, and what is kind of some checkpoints that you should look at along the way. So I kind of mentioned earlier on that this is kind of a hardware focus that we'll be looking at here, but I'm going to kind of go through and do some analogous layout for some different areas that you might have. So be it website design, mechanical, that kind of thing. The first step that you'll kind of want to do is this initial design phase for a prototype. So in electronics, what this is going to kind of look like is a schematics. So you may want to pick up a reference design associated with whatever product you're working on, and you'll be able to go in and kind of be able to have a starting point that allows you to see what the functionality of the board is going to look like. So you might need to do light sensing. There are reference designs available for it that will explain essentially how this board is going to work, where are the different inputs and outputs, and where's the power coming from, that kind of thing. And again, with website design, with mechanical design, what you're looking at here is this first initial step that is going to be on the way. So for a website, that might be wireframes. So you're kind of looking at, as I've built out the site, I have a rough idea of how this is going to look. It doesn't have any polish. There's no, essentially, there might not even be color in most of these cases. It's probably just a click through to be able to see this is how it should intend and function. And then for mechanical, that'll probably be your first run at a blueprint. So you'll take a look and start to say, rough sketch, I've done a notepad, and this is kind of the area that we're going to be working with. And that'll be finalized and refined as you do kind of more CAD design, but that'll be kind of your first step with it. In terms of the secondary design phase, so this in electronics is going to be your board layout. So you've defined essentially how it's going to function. You begin to pick some of the parts on the schematic. You should be working on a bill of materials, which we'll touch on here in a second. And now you're looking at how it's going to actually be designed in 3D space. Where are all my components going to lay? Where are all the parts going to be on the board? And why this is so important, we kind of talked about earlier with some of what we're doing with the visual prototype, is that if you're intending to be kind of a consumer device that is going to be handheld, you need to know how all those components are going to lay up so that someone could actually be able to hold it in their hand. So this is part of the defining stage to make sure that you're not going to have any issues with electromagnetic interference as association with your wires, as well as making sure that your components aren't all on top of each other, that you have enough space to be able to actually put all the parts that you need to on that board. Analogously, again, we talked about for websites, this will look kind of like mock-ups. So you'll have a rough idea that now I've added some color and the buttons potentially click and take me places, but there's no error checking, that kind of thing. And in mechanical design, this will be a 3D CAD model. So you'll be able to go through with something like SolidWorks and verify that your product is kind of where you are intending for it to be from a three-dimensional perspective, but you haven't necessarily gotten anything physical out of that done just yet. And then the final stage we're going to look at here is going to be this testing and quality stage. And this is really important. This is kind of the final step that you will have right before you start to do the production. So for a prototype board, at this point in time, you've gotten your printed circuit board made. You've done printed circuit board assembly, so all the parts are populated on there. And now you're just kind of running those final checks. You're making sure that those boards arrived as they expected, that the power is running where you would want it to be, and that essentially all the connections are functioning as you would expect them to. This is a really important step because if you have a prototype board, let's say you do 100, and a yield of your boards only gives you 50 that are working, then you need to make sure that you're relooking at that prototype design before you go to production so that you don't have most of them coming out that aren't actually going to work. Similarly, in this phase for website and mechanical, what we're looking at is that this is the quality assurance environment. This is really where you should be doing your final tests before you push live. You need to make sure that you're going through and verifying, and as you begin to build up longer term on some of the checks that you'll need to do, you'll want to make sure that everything that you had done previously is still working. So it's one that you're going to want to potentially script and go through to make sure that you're hitting all the different checks in the site that you had done previously. Similarly with mechanical design, this is a good stage to be able to do 3D printing. And there'll be some kind of overlap here with electrical in that as you do your plastics, as you do some of your enclosures and that kind of thing, you're going to need to do some level of the mechanical design. So making sure that things are laid out appropriately in terms of where they fit. But this will also be a good area for you to make sure that when you get it 3D printed, you can see, does it kind of fit the expectations of what I'm looking for with it. Okay, I'm going to go on to kind of talking a little bit about what these stages look like in regards to hardware. So for a schematics kind of phase of this is one of the ways that you're able to really show a representation of what your product is going to be and how it's connected. So this is kind of the theoretical design portion where we can go through and say, how is it going to be wired up? What is the function going to look like? Do all my wires have the function, the chips that I'm going to be using, do they have the functions I'm expecting to? So if you're starting a basic IoT design, you might need a microcontroller and a Bluetooth chip, and you'll want to make sure that you have the correct protocols to be able to communicate over those lines, be it SPI, be it I2C, something like that, so that you're being able to kind of get the right places on your product. So it's ideally defining how those lines are going to look, and essentially this is kind of where your schematic begins to shape itself. There are a bunch of really great tools out there for computer-aided design or CAD. What we tend to see is that we have a partnership with Cadence OrCAD. So if you go onto arrow.com, you can use OrCAD Capture Cloud for free, and it has symbols and prints associated with parts in the tool. So you're able to go ahead, pick reference designs off arrow.com, and begin starting your design right there in terms of going with it. There are other tools out there on the market that are very good. We can kind of, there's a bunch of them that I would recommend looking at. Design Spark PCB would be one that would be another good idea, as one of the persons in the comments I believe mentioned. But it's something that you should definitely be trying to start at a free level, and you will want to kind of progress upwards in terms of being able to do DRCs, design rule checks, and making sure that all your parts are hitting where you would expect them to. So at this point in time, when you've kind of gotten past the schematic, you've really defined all the parts that are going to be on your bill of materials. The next thing we look at here is essentially the board layout step. So you should have had parts defined in your schematic. They may just be resistors. They may just be capacitors that are defined at fixed values. You don't need to necessarily have all of those parts populated, but when you do need to go do the board layout, you need to know what size those parts are going to be. So in that regard, you're going to want to know, are my capacitors 0402s? Are they through holes? What is that going to look like? This is a big step in terms of being able to go through and visualize kind of longer term what is going to be, how big the size is going to be, and essentially how your traces run along your board. So it's important to make sure that when you're doing this step, as I mentioned earlier, you're not going to get any electromagnetic interference for these parts. And that's one of the steps that you're going to have to do, is to ensure that all of your parts are laid out appropriately such that your traces don't interfere with each other. Because if they do, what you'll have is your board won't be able to function properly. Someone could push a button or something like that, and you'll get unintended effects of what it should be doing. The next portion that we're going to look at here is then the bill of materials. So really the tied three things that you need to do for getting to board production are a schematic, a layout, and then a bill of materials. This is really where you should be defining what your shopping list of parts are. And you should be making sure that when you're doing this, that you have things that are going to be sourced appropriately, that they're going to be able to have a large amount of stock on them, so that you're not going to be able to run out of stock, or if someone buys them all out, you have a second source to be able to make sure that you're covered. And you also want to make sure at this point in time that you're trying to source them as seamlessly as possible, potentially through one provider. And so Arrow does feature a bill of materials tool that you can use. We have a link for it later in the presentation, and it's important to be able to, you can go in, use it, upload your BOM on there. It's very seamless, and make sure that all your parts are not going into life, they're not going obsolete. You can even share it with your kind of coworkers as you go along. And it's important to have an accurate BOM, as I kind of mentioned, to make sure that when you get ready to do a production run, that you're not running into a circumstance where the part is 36 weeks out lead time. Now you're set back a couple of months in terms of being able to do production. And really what you're looking at that point is, hey, I wanted to deliver to my backers in December. All my parts are a year out. I don't even know if I'm going to be able to get this board run. So making sure that your parts are in stock and available readily and easily. They're quality parts so that you know that they're not coming from anywhere that's counterfeit, and that you're also making sure that you have everything costed appropriately so you can hit your target price is important. And then we'll talk a little bit about, so what does a prototype cost? So in terms of a prototype as compared to a production board, the costs here are typically going to be higher for a prototype as expected, because of the fact that you're kind of using parts that are potentially commercial off the shelf, may have more functionality than you might actually need. And you will begin to strip things out of your design as you go along to make sure that it's essentially as bare minimum as you can get it for being able to do a production run. So when you're looking to kind of cut costs from a prototype, do know that there will be some areas that you can probably pull from, especially if you begin with an evaluation board or something like a Raspberry Pi or Arduino. That you'll be aware to know that there are certain functionalities you're probably not going to need, and you'll be able to kind of pull out over time, which should help you get closer to the price point you're trying to meet for your bill of materials. All right, so let's talk about pulling it all together, what the last kind of steps look like. So essentially, you're going to want to make sure that you're doing a physical prototype. You're going to want to get past the steps of what we had talked about with visual and the earlier on breadboarding, that kind of thing. And you're going to want to get to a point where your schematic's complete, you know what your layouts look like, those will be Gerber files associated with it, and you have your bill of materials vetted. It's important, too, to remember that you want to make sure you're getting components from high value and really quality manufacturers. So think people like TE Connectivity, people like Analog Devices, and you want to be using cloud services through partners like we have like IBM. All of those are options that are available through what we're working with the Arrow certification program. The next thing to look at is also a contract manufacturer. So the first kind of run that you're going to do may only be 1 to 100 boards, and you'll be able to work with a CM for that. But longer term, you're going to want to see how can I potentially scale upward from there. So what the contract manufacturers are really good at is these guys on a regular basis are retooling and rekitting their plant to be able to do multiple different productions of different boards. So they're really great in terms of being able to say, if your layout isn't done appropriately, they'll probably say, this looks like it could be potentially problematic. They'll have tools available for that. They'll also be able to help you kind of look from a sourcing perspective to say, hey, we're not going to be able to get this part. We don't know exactly when this will be available. You probably should look at where another component to be able to go in that design. And that's, again, where we can kind of help out, where the bill of materials tool can help out as well. And really, that's Arrow's bread and butter. Again, if you are kind of working on this step, definitely make sure that you're working with a local distributor. Definitely kind of be involved with people as you go along in that process. And there's really some benefits that we can kind of help with getting that part selection done. Okay, the final portion here is kind of just going through the Arrow certification program. So I know Nisha touched on this a bit earlier. One of the great benefits of getting to, of opting into the Arrow certification program is that you'll get a chance to consult with engineers. So essentially we'll kind of go through and be able to help answer some of these questions along the way that are kind of maybe stumping you of how you want to go about with your prototype. So if you have questions in terms of how is it that I need to move forward, what's my next step look like, where is it that I can get some value out of this, or just, hey, I'm kind of stuck at this, I'd like to know what it is that could help me out moving forward. That's a really great place for you to be able to get some of that technical advice, and we can kind of move forward with you and be able to get your product essentially off the ground, help you kind of get started on that front. So with that, I had a couple of different resources that we listed here, essentially where we've gone through and outlined some of what we do with design tools and kind of some of the articles that we've covered already on this content. I think I was going to open it up to Nisha to ask questions.
That was really awesome information. At this point, like Keaton mentioned, we are going to open up for questions. I know some folks were having issues with the audio or video, so I just want to say we're very sorry that was troublesome. We will definitely be sending out the presentation within 24 hours. So the full thing has been recorded with the Q&A session, so you'll get every bit of information from this webinar very soon. And just a reminder that if you do have a question, please submit it via the chat box below. First question, Keaton, for you is from Susan. And we had a very similar question from Lorenzo. So from Susan, my product has electronics components and I have no clue where to begin. And from Lorenzo, I have an idea and a business plan. I need reliable engineers to help me build my prototype. Can Arrow help with those things?
Yeah, absolutely. I think that's definitely one. These are the use cases we're talking about where we want people to opt into the certification program. So from those paths, if you're saying, I have electronic components that I need to integrate, or I need reliability, I need help kind of figuring out the next step, that's what we do on a daily basis. We see a lot of people come through that are entrepreneurs, and we want to help you move forward in your design. So we may be able to essentially point you in the right direction in terms of what is going to be your next step, where is it you might have missed technology pitfalls. In a lot of circumstances with some of these designs, people have never considered the security aspect of it. What if your design does need to have some more critical security applications for it? You never want to have a backer come back and say, hey, this didn't work as I was intending, and I have concerns now from that. So we want to make sure that we're going through and consulting with you to kind of give you a whole look at the high-level view of your design, and also kind of getting into, hey, what are some components that you might want to look at? Where can we make recommendations? How can we help evaluate what your design looks like?
Great. We have a question from Kunal. How can Arrow help to build a working prototype when the concept is just in an ideation stage?
So if your idea is in just the kind of ideation stage, what we can definitely do is show you, here's a basic path, here's code examples, here's some boards that I'd recommend getting started with. You really want to have a point, if it's just an idea, to get to that first proof of concept, like we were talking about, the first prototype today. So essentially at the point in time where you can kind of go through and say, all right, I have it up on an Arduino, I have it up on a Raspberry Pi, I'm using an evaluation board, I can prove the one key selling point of my technology. That's when you're going to have to start where you're going to start to build some real traction. And what we can do is essentially point you in the right direction to say, here's an example of something you might have overlooked or you might have needed to do, and here's some boards that have some example code of how you can get started with this and how you can kind of get whatever your key function is off the ground. And then from there, as you start to do that, you can add functionality based on what you need from that first couple boards.
Great. We have a couple of questions about contract manufacturers. Can you talk a little bit about how Arrow works with CMs and if you have any insight into that process?
So contract manufacturers are essentially, there's a couple of different tiers of contract manufacturers available. Most of the time when you're working on kind of your lower level prototyping, so going from anywhere from 1 to 100, there will be board houses that are local to you that are able to kind of help you get started off that. And Arrow has some partnerships essentially we work with to be able to make the process a little bit more streamlined. So we know essentially all the files that are going to be required. We can make sure that that first touch point with the contract manufacturer, you have everything that you need, and we can kind of make sure that all the products that are going to be going in there are what we should be expecting to send to a CM. We'll make sure that there's no long lead time on those parts. We'll make sure that they're not obsolete. We'll make sure that they're from the right manufacturers. Because really one of the key pitfalls that we find with contract manufacturers is that when people come in to do it, their bill of materials potentially has a lot of hangups in it, and then it's this back and forth constantly going through, okay, how do we replace this part? What do we do here? Do I need to redo portions of my design? We can make sure that before you ever hit that stage, we've talked to you about what are some of these things that you should be looking at, where can we make recommendations, and are these components readily available for you to do?
Great. We have a couple questions about the Arrow certification program, and I can actually touch upon a couple of them. So first off, does a product need to be certified before getting access to Arrow resources? The answer to that very quickly is no. You are able to get in touch with Arrow as early as you would like, and maybe Keaton, I'll let you kind of elaborate on when might be an ideal time to get in touch with Arrow.
So we definitely would recommend that you get in touch with Arrow before you go live with your campaign. If your campaign's already live, that's excellent. But if we have feedback for you along the way, we want to get it to you before you kind of hit the go button there. Because once that clock starts, we want to make sure that you are ready to run as quickly as possible. So with that, Once you've kind of gotten to maybe an early proof of concept, you've gotten that first technology done, it's a really good conversation point for us to be able to provide feedback. We can start as early as ideation. That first conversation, we can point you in the right direction and say this is where we would recommend going forward with it. But we definitely, the closer and the further you go along in terms of your prototype, the more valuable some of the advice we'll be able to give you will be. I mean, you'll be able to kind of point you directly to specific components that you might not have thought of, and kind of taking a look at your product at a very high level.
Great. I know we had a couple questions on specific design tools, and I know you recommended in your presentation Design Spark Mechanical. Any other recommendations from you? How would you go about choosing the right design tool?
Yeah, absolutely. So the tools that we have available on Arrow.com, we're going to have OrCAD Capture Cloud. That's going to be a schematic-based tool, and we have an offering there as well to be able to do board layout as well, as portions of your design. So OrCAD Cadence is the partner that we have on Arrow.com. Outside of that, design tools are essentially going to be that you want to, my starting point would be something that's free and that has some of the work done for you. So if it has a portion that you can leverage reference designs, if it has some of the symbols and footprints already baked in there, you're going to be saving yourself time from having to do so. So one of the benefits that we see with the Cadence tool is that we have essentially Arrow.com parts mapped on there. We have 2.78 million symbols associated with what's available on Arrow.com. And then you're actually going to be go ahead and it'll create a BOM for you live time in the background as well. So it's saving you time as you go. But definitely I would recommend start with a free tool, get used to the feel of it if you've never done CAD before, and then you can escalate and get more and more benefits like design rule checks as you go forward. Those obviously come at a cost, and a lot of these providers will have availability for it. But that's how I would recommend do it, is get started with a free tool, get your design kind of flushed out a little bit. When you hit the limits, then you can upgrade and kind of move on to more professional tools.
Awesome, thank you. We do have a couple questions about building V2 functionality into an existing prototype. Specifically a question from JD that says, what if you're in a situation where you have a robust working factory sample, but you want to add additional features that'll require reconfiguring the board? Can you iterate during the manufacturing process?
I think my recommendation in that circumstance in particular is if you have something that's working and you can go to market with it, then you would be advised to start to build that process. If it's a mandatory feature that's a showstopper, then you have to address it as it is right then. So, you know, for example, if you need IoT connectivity, that's becoming a really popular theme in a lot of the designs we're looking at, and it's going to be a complete respin for the board, but it is a showstopper, then you will have to start at that point. What I recommend to that is that if you could potentially leverage a reference design, a module or something like that, so Bluetooth module, Wi-Fi module, sensing, potentially what you're looking at, that's going to be the area that you want to play, so you don't have to worry about FCC certification if they're already pre-certified. It'll also essentially not have to do as much work. You can kind of leverage a lot of what's already been done for you. So again, in that particular circumstance, if it does become a showstopper and it prevents you from being able to do your MVP, then you need to start and make sure that you get that integrated, you know, just so your product's able to go. Otherwise, if you can start some of the building off of what your product is now and then work to a Rev 2 as your product in the marketplace, that'll be better for you overall.
Great. We had a couple questions around circling back with Arrow once you've actually built your prototype. So a question from Marianne: I applied and was accepted into the Arrow certification program, but I had to wait to actually get my prototype built. Do I need to reapply now that I have a prototype? How do I get back in touch with Arrow?
You should not have to reapply. What I'd recommend is if there's any questions regarding where am I at, what's my status, that kind of thing, we do have an email set up, Indiegogo@arrow.com, where you can send general questions based on it. It should be one of those touch points where we've worked with you in the past, we're familiar with kind of where you were at on your account, and you just kind of circle back and we'll get you in touch with the appropriate resource from our end. So my recommendation is you shouldn't need to reapply. We do keep everyone who's been a part of the program. We have a lot of customers who are active currently, and just make sure that you're sending an email to Indiegogo@arrow.com.
Great. We have a question around adding Bluetooth and cloud connectivity into your product. Do you want to maybe talk a little bit about how you guys work with IBM and other connectivity partners?
Yeah, absolutely. So from a hardware perspective, if you've never done chip versus module design, keep in mind that your modules are going to be more expensive, and that you're going to essentially be paying more for them, but then you don't have to worry about going through doing the actual certification for those, and being able to make sure that it defines the functionality. It's typically just an input-output where you can communicate to that processor. From a cloud perspective, one of the things that we look at is, so anything like Wi-Fi, like Bluetooth, that you're going to be communicating data with, we do have a partnership with IBM, and one of the resources that we can do through the program is being able to set you up with essentially a Bluemix account and help you kind of get started with some examples there. And why that's important, and some of the IBM cloud features as a whole, IBM Watson is something that is just fascinating in terms of a machine learning perspective, in terms of the way that you're going to be able to take your data in and get some actual analytics back out of it. So if you're doing anything that's going to be communicating over long term, we start to see these new pathways where potentially you might have done a physical product sale in the past, then you have no more information about what your customer did with it, then you have no insight in terms of how you want to build with it going forward. What are some new features you might want to add? As you start to look at doing some of these connected cloud IoT plays with something like Watson, you get feedback from your user in terms of how they're using it, and you could even potentially look at a new model where you're giving away the hardware and doing subscription-based for your software and your secret sauce. So hardware potentially becomes more commodity at that point, but if you're thinking about doing IoT, or if you're going to be doing Bluetooth, Wi-Fi, anything like that on your design, definitely get in touch with the Arrow certification program. That's a really great design start to be able to do. We can get you set up with some of the benefits from IBM.
Great. We have a couple questions about specific boards. So specifically a question from Kunal: what is better, Raspberry Pi 3 or Arduino board for making an AI-based prototype?
This is kind of weird. I've seen a couple of questions about this. So there are challenges in terms of building with a Raspberry Pi that you should be aware of. One of the big ones that we see is that the processing chip on a Raspberry Pi is a Broadcom-based processing chip that most startups and entrepreneurs are not going to be able to get access to. So if you build your prototype on a Raspberry Pi, you'll have the functionality, you'll be able to explain what you're doing, but you will have to eventually start essentially from scratch off of a Raspberry Pi because of the fact that you're not going to be able to get access to that chip for most people. I would recommend an Arduino or an Arduino-based system. Companies like ST Micro have a Nucleo-based device as well as Microchip. They have good products as well. An Arduino base is going to be better off for you because those are typically open source and the platforms are easy to see what components go on that design. There's a lot more leverage essentially to be able to take different shields and you could stack them if you need to kind of build this rough proof of concept. So it's a easier way to be able to transition into more of a full design later on. So if I had to make a recommendation between the two, I would recommend starting with Arduino, and there's a lot of great places to get resources on that. In some circumstances, Raspberry Pi is going to be your only option. That's typically high-end video processing. If you have an application like that, that's probably going to be where you end up starting. But again, as you go through, if you have questions about which technology might be better, if you have a particular use case that you're looking at, then you can always reach out to us and we can help you out with that.
Great. We have a couple questions kind of circling back to the cloud connectivity stuff about other partners that Arrow might work with aside from IBM. I know AWS was brought up a couple times. I don't know if you have any more insight into that.
We do. So Arrow has partnerships with all of the main lines essentially. We do have our own way to be able to engage with those companies. So if it is something that you are looking at, and Amazon Web Services, if you're looking at Microsoft Azure, Google, we're even aware now that Salesforce is doing their own base platform for this. Arrow has connections with all of the partners, so we're more than comfortable having that conversation. IBM is the partner for the certification program, but if you're already leveraging something, if you're already using cloud connectivity, Arrow will be able to provide and help you with those other places. So definitely know that we do service all of the main manufacturers and that you would expect to do cloud services.
Thank you. We have a question from Rebecca that says, will Arrow fund products that are not electronic, like kitchen products? I can touch upon that one a little bit through flash funding, which is offered through the Arrow certification program with Indiegogo. Eligible products will only be hardware products with electronics components. That's specifically for the flash funding that's offered through this program. So I just wanted to clarify that a little bit. We did have a question, Keaton, on NDAs. What's your policy on NDAs or privacy regarding intellectual property in regards to the one-on-one consulting for electronic products?
Yep, absolutely. When someone goes to be able to opt into the Arrow certification program, you will have the option to be able to do an NDA with us. It is something that's pretty standard that we work on at this point. Just as a kind of overarching theme here, Arrow's not out there to go after your IP. We're not out there to try to be able to remake your product or something like that. We are aware of kind of the challenges, but we do NDAs with all of the customers that we work out in our field as well. So it's something that's very common practice for us and we've worked with for a long time. If you have concerns with it, we can definitely make sure that at the start you are getting the NDA filled out so that there's essentially you have that non-disclosure agreement. But when we're looking at it from an engagement perspective, my job essentially is to help make your product a reality. We want to get you as close to production as possible, and it's taken you essentially from that ideation phase to prototype and to production. So I will be looking at it as sort of a, how can I help you? How can I help you move forward? What is the best way that you're going to be able to benefit from it? And it's not necessarily a play after how can we be able to build your technology. We want to just work on kind of moving you forward, getting you close to production, as it'll benefit both companies.
Great. We have a couple questions about timeline. How long should you plan to be in that prototyping phase? How long does prototyping typically take?
Yep. So from a timeline perspective, when you're looking at when you should be launching your campaign and then also when you're going to be doing prototyping, you want to have most of your functionality determined probably about 3 months before you're going to be able to go into this. So if you're not familiar with doing schematics or layout, you're going to want to allocate probably more time. I would easily say, 6 months, that kind of thing. But the more polished your product is when you go to launch, the better off you're going to be because you'll be closer and backers can really see the reality of what you're going to be getting out of this product. So if you look at it and you say, I've determined I have 1 or 2 functions done, but there's another 10 that need to be there, you probably need to be closer to having 11 of them done, 10 of them done, that kind of thing, to make sure that you're at a point where most of your functions are defined and you can work on the rest of them as you go. I think, just kind of from a general perspective there, make sure that when you're ready to turn that switch that you have all the intended functionality and the product actually kind of starts to look like what you want to do. Because once you start that, you're on the clock. And if you run into any hiccups like we've seen with bill of materials in terms of sourcing or in terms of a layout issue, you definitely don't want to get behind the 8 ball on that. So being as close as possible as you can to kind of this first factory sample is really the ideal stage. So again, I would say a couple of months is really where you need to be, and that flows out more based on how many functions you need to continue to develop as you're going along.
Great. We also have a timeline question around Arrow certification. I can say that it'll definitely vary from product to product depending on what stage you are in. But maybe, Keaton, if you can run through, how to qualify for Arrow certification and what you need to have ready to get that certification badge, that would be very helpful.
Yeah, absolutely. So the main things that we're looking at when people are coming in for getting their technology certified through Arrow is we're going to go through and we need to look at your bill of materials, and we'd like to have a high-level block diagram for it. And this kind of goes back to some of what I was talking about in the presentation, in that we want to make sure that you're not going to have any stocking shortages. We want to make sure that your parts aren't going to go end of life. We've seen a couple circumstances where people will come through, they found a product that they really love, they're really excited about it, and oh, by the way, the lead time on that product is, again, somewhere in the 28 to 36 weeks time frame. And so really when you're looking at how do I acquire these components, your design's already been pushed out a couple months, 9 months at that point in time, and if you need to acquire those parts, you better hope that they're available and easily to go to. So when you come in for the Arrow certification program, we're going to want to make sure that we do look at the bill of materials and block diagram. Those are the two that you'll want to do, and then we can help do some of the consulting from there in terms of how we can affect that.
Great. We have a similar question about what are the conditions specifically for flash funding. So I can definitely touch upon those a little bit. So to be eligible for flash funding, you have to have a product or technology that is Arrow certified. So you do have to meet those requirements that Keaton just outlined. You also have to have an Indiegogo campaign live on the Indiegogo website. That can also be an in-demand campaign. It doesn't have to be just the original crowdfunding campaign. And in addition, you have to be based in the US, in Canada, or in a list of select European countries. You can refer to the flash funding terms and conditions that are posted both on Indiegogo's and Arrow's websites for which specific countries are eligible. Cool. We have one more question from JD. What if I have a working functional custom board that you've already designed? Will you help connect us to the right people to price out manufacturing at scale?
Yeah, we can absolutely do something along those lines. If it's something that you already have a working board and you just kind of need to look at how do we do large scale production, Arrow does have services to be able to provide for that. So we do have manufacturing services available for it. So if it's something where you already have it, you have a first product sample that you're done with, and you need to be able to move towards more of a large scale, that's definitely something that we can help assist in the way of pointing you to potentially good partners that you would want to use, and also could potentially be local to you or wherever you're looking at doing the manufacturing.
Great. That's a good question. Oh yeah, that's a great question. So from Imrich, what are the main things that you see entrepreneurs get wrong when building hardware products?
Oh man, do we have another hour? Okay, so hardware products, the couple of things to think about. One, when you go to start building this hardware product, as I mentioned with some of the Raspberry Pi integration, if you aren't building off of something that is easily accessible to you, you will hit a pitfall pretty quickly in terms of you've made your design, everything's working great, and then you're not able to actually go through and build a board. The second thing to think about as well when you're looking at a hardware product is, do you need to think about security of your product? Is it going to look, do you need an encryption chip? Do you need to be able to look at if you're doing cloud services associated with it? How are those lines of communication going through? How are you defining essentially what it is that you need to be able to make sure that your data is not getting out? A couple other things to keep in mind whenever you're working on anything that emits a signal, be it Bluetooth, Wi-Fi, LoRa, Zigbee, all of those protocols, they are going to be emitting waves, and so you're going to have to do some sort of FCC certification associated with those products. So that'll either be, if you haven't used a module, there's costs associated with getting your product FCC certified, and it's also picking the antenna, make sure that you did essentially the right matching on that so that you're getting ideal waves. There's a ton that goes into that portion in itself. Again, if you've never done Bluetooth or Wi-Fi before, I highly recommend looking at certified modules that you can just place on your design to help you move forward in terms of being able to get off the ground from a Bluetooth and Wi-Fi perspective. Outside of that, the key thing to remember when you're doing hardware is look at the life cycle of your product. If it's something that is looking to be 10 years out, make sure that the components that you're placing on your board and you're choosing to design with are not going to go end of life in 3 years. Otherwise, you'll have to do a complete respin of your product, and that becomes potentially challenging. Once you've gotten a first design done, it's significantly easier to leverage that when adding features than it is if you start with something you have to completely drop everything you're doing and rebuild the first board that you had. So again, FCC certification, making sure you have easy access to the components, and making sure that the products are going to be in life cycle and essentially in stock available for you longer term.
Great. We have a question from Dom that kind of goes back to what is necessary for Arrow certification. So I have a factory sample. Is that ready for Arrow certification?
Yeah, so if you have a factory sample, what I am assuming it goes along with that is you should have Gerbers associated with your board, you should have schematics, you should have a bill of materials. So in order to be enabled for Arrow certification, you would need to opt into the program and then send us the information on the bill of materials that you're working on, that essentially your factory sample was built off of. So that's actually a pretty good place that you'll be in. You already should have most of that information and know what parts that you're working with. And essentially, once you reach out to us and be able to kind of share some of what you're working on there, we'll verify that it's feasible. If you already have a product built, then I'm sure that we will be able to kind of have a better conversation in terms of what are some trouble parts and that kind of thing. But you should be at a good stage to be able to move forward in the certification process.
Great. One follow-up question on IP. Is IP shared with a contract manufacturer if you're going through Arrow?
So the relationship that you have with the contract manufacturer is going to be, Arrow essentially helps with that process, but what you're looking at is when you're going to get your boards built, you're really going to just need to share your Gerbers and your bill of materials. So in the bill of materials, I've kind of liked to explain this analogy before, is that I see it as kind of your list of ingredients for a cake. And the same cakes are made, essentially, they have similar ingredients all across the way. So sharing that, someone could easily crack up in your product and be able to see, hey, here's all the parts that are on the board. That's done very regularly. So from that perspective, I typically feel pretty comfortable sharing bill of materials on a product that I would need to. But if you have concerns over it, it is something that we can kind of be more generic about. Gerbers are more just kind of showing how your board is laid out associated with it. Those are important because if you're not able to share your BOM and your Gerbers, you really can't go for and be able to build it with the contract manufacturer. Now, we're not going to be sharing any of how you do your software. We're not going to be sharing how any of the firmware on the product. We're not going to be going through and talking about anything you've told us in terms of second rev, that kind of thing. But you will need to have some basic documents that you're able to share in order to just be able to even engage with the contract manufacturer at that point.
Great. One more question. Is it okay in the hardware industry, and maybe more specifically for Arrow certification, to take apart other products and embed it in your prototype? For example, Bluetooth headphones.
So one thing to keep in mind when you're looking at doing that is you are expecting to be able to source that product and be able to pull those parts out of it. So I would highly recommend that if you're going to go that route, you figure out what technology is in there that you want to use and then build your own boards, because you never want to have a circumstance where, say it's Bluetooth headphones, you're buying them and you're taking them apart and you're pulling these parts out, and then that company goes out of business and now you don't even have a product anymore. So I would genuinely highly recommend that if you're looking at something like that, figure out what is going on in there, if that's what your plan is going to be, and then make sure that you're actually using those technologies on your own board. I would seriously very much recommend that you spin your own board at that point. There's a lot of pitfalls that could come from using someone else's product.
Cool. And just to clarify that question, you was referring to a presentation prototype, not necessarily a final prototype. So I think, yes, for presentation prototype, it's a little bit better. I think for an Arrow certified prototype, probably not.
Yeah, for presentation, if you want to just be able to showcase about like what it's going to look like, if there's a form and factor that you're saying this is similar to what we're doing, that's good to be able to show people what your product might look like. Yeah, sorry to get on a rant on that, which is that's a high portion of challenge. So make sure that if it's a certified prototype, don't be doing that. But yeah, presentation, that should work.
Question, can we use Raspberry Pi in our product without NDAs?
So yes, you will be able to. Again, the challenge that ends up coming with Raspberry Pi longer term is that when you go to build at mass scale, it's really challenging to be able to do that in a time-efficient manner. So let's say you have 100 boards that you need to build with Raspberry Pi. Every single one of those, you're going to have to get an SD card. Every single one of those, you're going to have to load the operating system on there. Every single one of those, any sort of wiring that goes associated with the Pi, you're going to do. And pretty much all of that work is going to be manual. You're going to have to go through and upload it on the SD card, then physically put the SD card in. And just remember that if you go to ship your product and that SD card comes out or is damaged in any way, your Pi may not work at all. So just when you're looking at Raspberry Pi, make sure that you know that when you go to build 1,000 boards, or even honestly 100 boards, make sure that you're ready to do that time-consuming product. If you want to launch your first rev with it to start just getting some sales in and kind of go from there, that's an acceptable way of going to market. That's totally fine. But remember that essentially longer term, when you're looking at that, there's a lot of areas of troubleshooting that you could have. There's a lot of areas that you may not be able to source that eventually. If you build with a Pi 3 and they move away from that form factor, they do a different board, where's your product going to go? So it's definitely something that you can do at lower scale volumes. When you go up to thousands, tens of thousands, and you really want to build your company out, significantly more challenging to do. So like I said, kind of make sure that you're keeping in mind where you want to go with your product.
Great. With that, I think we do have to wrap up. I know there are a lot of questions from specific individuals about their own products, components, specific timelines, and pricing. So as Keaton mentioned, please feel free to opt into the Arrow certification program. You can do that both on Indiegogo's website at enterprise.indiegogo.com/arrow, or also feel free to email indiegogo@arrow.com. I know Keaton very much checks that email on a regular basis, so hopefully we'll be able to get back with some individual questions answered as soon as possible. I just want to thank everyone for joining us today, and have a great day.
Thanks, guys.